to be impact crater.
Disoriented. Holy shit. Wait, Ben. The suits aren't ready for that kind of cold.
Moonlight is not like sunlight. It does not warm. It does not dazzle. It simply exists. A pale reflection suspended in absolute stillness above a silent earth. For thousands of years, we looked up and felt a singular constant of stability. But that feeling, it was never real. Look out there, at our neighbors. Mercury is lonely. Venus is burning yet empty. Mars has only 2 tiny fragments of rock drifting around it. In the entire solar system, no other rocky planet possesses a satellite as massive, powerful, and absurdly perfect as ours. Why is it there? Why is it hanging in that exact position to keep this planet from tumbling into the void? Without the moon, Earth would be a dead land, chaotic and lifeless. Every other planet met a grim fate for lacking a night watchman. So, where are their moons? Or rather, why were we the only ones chosen to possess such an anchor? But look closer. The moon is not still. It is shrinking. Nearly 150 feet of its circumference has vanished. A small number, but in astrophysics, it is a geological suicide. The rigid crust is squeezed until it shatters, tearing the surface apart from within. The heart of our only companion is shriveling like a raisin. The moon isn't just withdrawing into itself. It is trembling. Moonquakes lasting for hours are unfolding in the absolute silence of the vacuum. This raises a suspicion more chilling than any scientific hypothesis. Is it truly a random celestial body or an observation satellite, an entity placed into orbit to watch over life, to monitor the cramped cage we call Earth? And when the symbol of permanence begins to self-destruct, is it pulling our entire reality down into the abyss along with it? Planets do not age like we do. They do not wrinkle like flesh. They shrink. As the lunar core has shed its heat over billions of years, it has contracted. Like any object growing cold, it withers. Not too dramatically, not too catastrophically, but it is enough to change everything. Look out there. Mercury and Venus, rocky planets like ours, are completely orphaned. Mars has only 2 insignificant fragments of drifting rock. Only Earth possesses a night watchman, so massive and absurdly perfect. Why only us? Why is it hanging in that exact position to keep this planet from tumbling into the void? Is it truly protecting us, or is it struggling to fulfill a forced mission that has lasted for eons? And now, the machine is overstrained. Scientists estimate the moon's circumference has decreased by 150 feet. That number sounds minuscule until you look at the lobate scarps, jagged cliffs tearing across the surface. They don't look like natural geology. They look like stress fractures on the hull of an ancient machine, compressed by immense pressure. The skin of a world, tightening over a cold steel core, like a piece of fruit forgotten too long in the dark. Withering, shrinking, freezing. The moon is not eroding. It is collapsing into itself. But the most terrifying part isn't the cracks, it's what happens beneath them. On Earth, the ground is like a sponge. It absorbs and dampens shocks. But on the Moon, the ground is a perfect conductor. Every time a new fracture appears, it triggers moonquakes that last for hours. These vibrations ring through the bedrock like a massive glass bell being struck, echoing over and over in the silence of the vacuum. How could a celestial body vibrate for so long if it were merely solid rock? Data from the Apollo era tells a different story. Our companion isn't just growing old. It is writhing in the contractions of a rusting mechanical structure. It has kept watch for too long, and now the final gears are beginning to shatter. The question isn't when it will stop. It is this: when this machine collapses, where will our anchor drag us? Earth is a living body. It has oceans to absorb impulses. It has an atmosphere to soothe collisions. It has tectonic plates to flex and to heal itself. But look at our neighbors to see the anomaly. Mercury is barren, scorched by the sun. Venus is suffocating in acid clouds. Mars has only 2 tiny fragments of rock, Phobos and Deimos. Useless satellites incapable of keeping the planetary axis from wobbling. Only we possess a massive regulating device, a structure with a ratio so perfect it's absurd. A stroke of luck or a deliberate design intended to nurture life. Unlike the geological mercy of Earth, the Moon does not know how to bend. It has only rock, cold, rigid, and ruthless. When the pressure of contraction builds within its steel, like core, it does not deform. It breaks. A clean and definitive fracture. The lobate scarps we see are not ancient relics. They are young, under 100 million years old. In the cosmic timeline, they happened just this morning. The Moon is not a dead world. It is a world holding its breath under the compressive stress of a structure shrinking to its absolute limit. But here is the part that mainstream reports always seek to evade. In the permanently shadowed regions of the South Pole, where light has never touched, seismic sensors have recorded signals unlike any natural earthquake. They aren't random tremors of rock and soil. They have a rhythm. They repeat, like an engine desperately trying to restart in vain, like the pulse of an entity being strangled by its own crust. Is our night watchman truly a random block of stone, or an ancient observation station slowly failing after billions of years of operation? Why should we be afraid? Because when a grand constant like the Moon begins to crumble from within, it's not just the story of a celestial body 384,000 kilometers away. It is the collapse of a control system. Have you ever wondered, when the Moon's geological heartbeat becomes chaotic, will Earth's tides and axial tilt remain as faithful as before? Or are we witnessing the fraying of the very chain that holds this planet back from the chaos of the void? The anchor is letting go, and when it finally falls silent, humanity will have to face a universe for which we were never truly ready to survive on our own. When the Apollo astronauts placed the first seismometers on the lunar surface, they expected the absolute silence of a dead planet. a mute block of stone whose geological heart had stopped beating billions of years ago. But what they received from the data tapes was a startlingly different reality, one that left the sharpest minds at NASA in awe. Moonquakes. Deep tremors emanating from the core. Jagged fractures tearing across the surface. But there was an anomaly so absurd, it defied logic, unlike Earth, where vibrations quickly dissipate into a soft crust. Here, they linger. They echo. They reflect and repeat. For minutes, sometimes for hours on end after a single impact. Ask yourself, why such a terrifying difference? The answer lies in the very nature of the structure beneath our feet. On Earth, the ground acts like a giant sponge, soft, porous, filled with water and complex sedimentary layers. It absorbs, dampens, and neutralizes every impulse. But on the Moon, the ground is not a shock absorber. It is a perfect conductor. It is like striking a massive glass bell with a stone in the middle of a vacuum and letting it ring forever. The Moon isn't simply vibrating, it is echoing its own fractures, the contracting pressures strangling its inner core. It is narrating its own slow collapse through every bone, chilling rhythmic resonance. Imagine standing alone near the Shackleton crater at the South Pole, where darkness is eternal and temperatures are so low that atoms almost cease to move. A fault shifts, a landslide begins. Not fast, but unstoppable. The fine regolith slides away in the absolute silence of a vacuum. You won't hear the rocks falling. You won't hear the crashing of debris or the thunderous roar as you would on Earth. But right beneath your feet, the ground is shaking violently. A deep pulse, a resonant frequency vibrating through kilometers of solid bedrock. No air, no sound. Only pressure and a chilling sensation that the ground itself is remembering and amplifying every crack it has ever endured throughout history. That hours-long resonance is a massive question mark that mainstream science often seeks to evade. Why can a natural block of stone sustain vibrations for so long? Why doesn't the energy dissipate? These tremors are more than just mere geology. They are evidence that the Moon's structure is changing, deforming much faster than what we were ever taught in textbooks. As the Artemis missions scramble to return humans to this harsh South Pole to build the first outposts, we are forced to face a life or death question. Are we stepping into a collapsing house? Is our night watchman truly a solid natural satellite? Or is it a hollow structure nearing its ultimate breaking point before shattering completely? Today, humanity no longer looks at the Moon as a mere symbol of romance. We are preparing to return. But the target this time is not the sun-drenched flat plains where Apollo astronauts once left those first historic footprints. We are aiming for a frontier far more unforgiving and brutal, the lunar South Pole, a land of extreme contrasts, where darkness is eternal, where water exists as ice as hard as steel, and a landscape molded by ancient impacts and silently active geological faults. This is exactly where the Artemis program is pouring its resources. The reason is simple yet ambitious. Buried within the perpetual shadows of these craters is ice, water, fuel, the key to survival. The future of a long-term human presence beyond Earth depends entirely on what lies deep within that darkness. But there is a chilling detail that the glowing promotional reports rarely emphasize. The very regions harboring those precious ice deposits are among the most geologically unstable areas on the entire celestial body. Steep slopes, fractured terrains, and fault lines are still silently contracting under immense pressure. We are planning to build fortified bases directly on top of massive rifts that we didn't even know existed 50 years ago. This isn't a foolish oversight by engineers. It is a high-stakes life or death calculation. A harsh truth has emerged. The same powerful contracting forces tearing the moon's structure apart are the very forces that created the cold traps, the deep basins holding the resources we crave. Imagine a human outpost, fragile and solitary amidst the deep shadows of 200 degrees below zero. A tiny, unannounced shift of a cliffside, a silent but intense tremor pulsing through the dense bedrock beneath your feet without a single sound of warning. The ice that could sustain us, helping us manufacture oxygen and rocket fuel, is guarded by a geological instability that could crush billion-dollar structures in mere seconds. We aren't just going back to the moon to plant a flag. We are stepping into a sophisticated trap set by nature, a place where the source of life and the threat of death are so tightly interwoven they cannot be separated. The real question for our generation is no longer whether we have the technology to land there. It is this: how long can we stand on ground that is constantly crumbling and swallowing itself beneath our feet? Once we listened to the moon, carefully, constantly. From 1969 to 1977, seismic instruments recorded its every internal breath. Then we turned them off. The data stopped. The listening ended. Once thought it was a galactic corpse. We were wrong. For nearly 5 decades, we have had no direct seismic monitoring on the moon, no continuous records, no real-time understanding, only fragments of ancient data and outdated assumptions from the last century. Meanwhile, the moon continued to change. Silently, unobserved, unheard. There is something truly unsettling about the thought, a world still active, still trembling, still tearing itself apart. Yet not one of us was listening. 50 years is but a blink in the cosmos, but it is more than enough for a celestial body to molt. We prepare to return with old maps, believing we understand every crater. But the truth is, the moon we left in 1972 is not the moon of today. It has shrunk further. It has fractured more, and perhaps it has grown more ruthless. Its crust has been compressed to its limit throughout half a century of solitude. The question is not whether we can return. It is this: when we finally press our ears against that gray soil once more, what will we hear waiting for us in the dark? A normal geological heartbeat, or the snapping of a structure on the verge of total collapse? The moon is changing, and perhaps it no longer wants us there.